Hey guys, we're going to apply the Newton's second law to friction. So the very beginning of this section, I gave you a little pun on formulas, and I said this. I said the F equals. So I said physics is fun, and so I kind of like to play with that a little bit and say that physics is fun. You may find it fun. I don't know. I enjoy it. But what we're really looking at is the force of friction on an object is equivalent to a, we call this coefficient. The coefficient of friction multiplied by the normal force on the object. Okay, so we have two types of coefficients of friction. We have mu sub s. We have mu sub k. Okay, s is for static, and k is for kinetic. Okay, kinetic is motion, static is still. We're generally going to use this one a lot more, but we will consider this one in some cases. Okay, so this is the one we're going to use quite a bit more. Now, this coefficient of friction can be found in any physics textbook, and can be applied, and I will always give you that number. Okay, so it's just a number. Okay, the smaller the number, the less friction it has. So let's get into what all this means with Newton's second law. So let's look at a problem. Okay, I've got a 10 kilogram box. I've got a force applied of 20 newtons. And let's say I've got a force of friction, we'll say force of kinetic friction of 10 newtons. Okay, now let's not forget that we've got to draw in all of the forces here on this box. Okay, this is a semi-free body diagram. This is more of a real-life diagram, but let's look at it in terms of this first. So let's first of all figure out what kind of net force is on this object. Okay, so net force equals the sum of all the forces. So all forces added up. Okay, well, let's do that. Net force equals, well, let's see what we got here. Weight normal force. Okay, we know that these two are equivalent. So the weight is the mass times the gravity, as you've learned. 10 kilograms times gravity. Okay, so the weight is 98 newtons down. The normal force has to equal this because we're not accelerating up or down, we're going sideways. So the normal force is positive 98 newtons. Got that there. So these two can cancel out. These aren't going to really contribute to the acceleration of this whole deal. So the sum of forces, what's left is a 20 newtons positive plus a negative 10 newtons. That's our frictional force, applied frictional. So the sum of forces is equivalent to 10 newtons to the right. You can also put an arrow on the top and represent it that way. Okay, so we know that. We know that we've got force equal, the sum of forces, or the net force, is 10 newtons. Okay? Keep in mind you can stop this at any point and rewind and go back to it. But this is how we get the net force on this object. Now, let's just say that we're trying to find the acceleration of the object. Okay, we know that acceleration is going to be in the direction of the net force. So net force is mass times acceleration. Solving for acceleration. Okay, acceleration is net force over mass. So we can easily, with this stuff, find the acceleration of this object. Okay, so what we're looking at is net force over mass, 10 newtons, over the mass of the object, 10 kilograms. The acceleration is going to be 1 meter per second squared in the positive direction. Okay? So we've got the acceleration as being 1 meter per second squared to the right. So we'll put a positive sign on that. Now, in some of these cases, so I've given you that frictional force. That's all set. I gave you the 10 newtons. Now, you're probably wondering, hey, where does this fun formula come in? Well, that fun formula comes in when I don't give you this force of friction. All I'll give you is the coefficient of kinetic friction. Okay? So we'll do one like that. Okay? And I'm going to set it, I'm going to leave this formula on the board here. Okay? I'm going to erase some of this other stuff and leave that formula. Okay? I'll rewrite it. Okay, so clean this up a little bit better. Okay, so now same situation. Let's draw the block here. Okay, I give you the mass of the block of 10 kilograms. Okay, we know the mass is 10 kilograms. I'm going to give you the applied force. We'll say 20 newtons. We're going to say that there is a frictional force. We don't know what it is. Okay, I'm going to give you the mass. I give you the weight is mass times gravity. The mass will be 10 kilograms. The gravitational pull weight's 98 newtons. The normal force is 98 newtons. Because it's not accelerating up or down, these two actually have to cancel. So we don't know what the force of friction is, but I am going to say that these two surfaces, let's say this is a piece of metal, say iron, and then this is a piece of glass. Well, I'm going to give you a fictional coefficient of friction between metal and glass. Let's say it's 0.12. Okay, and that number, this coefficient of friction, it can be found in any chart in any physics book, or even online you can get a lot of these coefficients of friction. Okay, so my question is, okay, what is the acceleration of this block if I tell you that there is this much coefficient of friction in between these two surfaces? Okay, so now we can take an approach with this, and we can say that we know that the acceleration is the net force over the mass, okay, using our F equals ma. We can just rearrange the formula. Okay, now this is a good starting point because we need to get the acceleration. Okay, so we don't have this yet. We do have this. Okay, so let's take a look. Acceleration is equal to the net force, which all we have is 20 newtons plus the force of friction. So what we have left is this and then this. Now we know this is going to be a negative number, so eventually this will subtract. And then this will be over the mass. Now, we're going to go back to what this actually is. Okay, and we said that the force of friction is mu times the normal force. So I'm going to replace this variable for these variables. Okay, and watch how I do that. Acceleration is 20 newtons plus mu times n. Okay, so acceleration is 20 newtons plus, and all I did was I just changed this mu sub n and I put it in place here because we know that that is equivalent. In physics, you're going to have to do that a lot and replace variables. Okay, now looking at the picture, we can say that the 20 is positive and this force of friction, or mu sub n, is going to be negative. So when we're adding these up, okay, we've got to understand that this is a negative number. Okay, so acceleration is 20 newtons plus negative mu. We got a mu value here. Okay, of 0.12. We've got a normal force of 98 newtons. So this here is equivalent to the force of friction. Okay, this one here. So if we go on the calculator and we figure out what's happening here, acceleration is 20 newtons minus 11.76 newtons. Okay, this is now the frictional force. So if you were to look at it, now we've got a frictional force. We figured it out, 11.76 newtons. So it's pulling this way. So just from a visual perspective, we could say, hey, look, I got 20 pulling this way, 11.76 pulling this way. So from a mathematical perspective, we can look at it like 20 minus 11.76. Okay, now acceleration is all of this divided by the mass of 10 kilograms. Okay, divided by 10 kilograms. Acceleration is 0.82 meters per second squared. So here's our final answer. Okay, we figured out all the top stuff, and then we divided by the bottom. So there should be a mass on the bottom here, a mass on the bottom here, and a mass on the bottom here. So 0.82 meters per second squared. Okay, I know that was a long video, but it really does cover most of the frictional stuff in accordance with Newton's second law. All right, thank you and have a great day.